So last time we did that little activity with the string, right? Where we drew a circle, we cut a piece of string to match the length of our radius, and then we took that string and we laid it along the outside of the circle, right? Okay, I'm kind of catching you up too a little bit, I know you're gone. So we cut a piece of string the length of our radius, and then we laid it along the outside edge of the circle, and wherever that string stopped, we drew this, all right? And then that angle that we created right there, I taught you, was called an angle whose measure is 1 radian, okay? So I want to give you a precise definition of a radian here today. Okay, so that way when I ask you on the test to define what a radian is, you have a very good, clear-cut answer as to what a radian is. Alright? So how did we get that measure of that angle? Well, we took that radius and that length and we laid that string along the edge of the circle, and the angle that that created right there is exactly our 1 radian measure of an angle. Okay? So a radian simply is an angle measurement whose intercepted arc, the intercepted arc would represent a portion of a circle, okay? An angle measure whose intercepted arc, that length, equals the length of the radius. I know we said it was about, 57.3 degrees or something like that, right? Okay, roughly. That's not super important to know. Yeah, it's a little bit less than 60. If you remember that, that's fine. Okay, and that's not something that's really important, but it's good idea to know or be able to kind of figure out. You don't need to know it's 57.3 exactly or anything, right? So a radian really is just another way we can measure angles. All right, 1 radian is about 57.3 degrees. But what we really got into was why the circumference formula works. Okay, because remember how the circumference for a circle is 2 pi r, and the reason that that's the formula for a circle is because it's basically telling you how many radiuses, whatever it is, okay, how many radii it takes to go around the circle. It takes 2 pi radii to go all the way around the circle, or 2 pi r to go all the way around the circle. So that's also why then 360 degrees is the same thing as 2 pi radians. They are equivalent amounts. Okay, 360 degrees is 2 pi radians. They're the same thing. Like 12 inches, 1 foot, they're the same thing, right? 3 feet, 1 yard, they're the same thing. Okay, you can measure lengths using different units. You can measure angles using different units, degrees or radians. On your calculator, you all have a mode that says degrees or radians. You choose which one you're in. If the problem is working with degrees, make sure you're in degree mode. If the problem is working with radians, make sure you're in radian mode. Questions so far? So far so good? Okay, all right. So that's what a radian is. It's an angle measure. It's a different way to measure an angle. Okay, it's a little bit less than 60. Its intercepted arc is exactly the same length as the radius. Okay, this is a test question, by the way, where I'll say define a radian, and you'll want to give a very good definition. Okay, it's important to know to be able to convert from radians to degrees or degrees to radians. We've talked about this. 360 degrees is the same thing as 2 pi, right? Okay. 180 degrees would be what?
Pi.
1 pi. 90 degrees would be?
Pi over 2.
Half pi, right? Or pi over 2. Yep. Yeah, and then Paige, you were thinking?
Yep.
2 pi.
3 pi over 2.
3 pi over 2. Okay? Because that's like 1 and a half pi. 3 over 2 is like 1 and a half.
Yeah.
Okay with that? Okay. And obviously there's a lot of, these are just a few angles, all right? Your unit circle has a bunch more on it, okay? But this gives you a little bit of an idea. 0 degrees, 0 radians. 90 degrees, pi over 2 radians. 180 degrees, pi radians. They're the same thing, it's just a different way to measure angles. We use them because they're a little more exact. They're not such a huge number, all right? When we get to graphing, you're not going to want to graph 360 degrees, 360 in the x direction. You're going to want to keep it in terms of pi, all right? Keep the numbers a little bit smaller, okay? So that's kind of why we use them. One of the big goals for today is convert all angles from degrees to radians, or if I give you a radian measure, to convert it to degrees. That's kind of one of our goals, our learning targets today, okay? It's pretty simple. Let me refresh your memory. What if I said, I want to know, 53,000 seconds. I want to know how many days is that? 53,000 seconds, or maybe it's not even a day, I don't even know. But if I said to convert that to days, what would you do? Little dimensional analysis, little physical
Divided by
science.
60, divided by 60.
When we multiply it by,
1 over 265. Or 1 over
60 to get an hour. And
it
then
takes
divide by
60 seconds to get
1 minute.
1 minute, right?
1 hour.
12.
I almost said 1 hour too.
And then it takes
60
60 minutes
to get an hour.
to get 1 hour,
24
hours
hours
to get a
in
day.
1 day.
and 24 hours in 1 day, right? Remember this?
No.
Physical science, algebra, we did this in Algebra 1, did it in chemistry.
I died in chemistry.
Okay.
It's not even.
This is called dimensional analysis, where you change from one unit to another. Unit conversions, okay, maybe is also what it's called. You used it in stoichiometry, but it's dimensional analysis. You're changing the dimensions or the labels, basically. Okay? Now, so I started with this 53,000 seconds, okay, so 53,000 over 1. Why is it okay for me to multiply by 1 minute over 60 seconds?
Because 1 minute is 60.
Because 1 minute is 60 seconds. These are the same amount. If you have a fraction, 7/10, and I multiply the top and the bottom by the same thing, that fraction hasn't really changed, has it? 21 over 30 is the same thing as 7 over 10. It doesn't change its value. So if you multiply the top and the bottom of a fraction by the same thing, like we do here, 1 minute, 60 seconds, they're the same thing. Okay? That's okay to do, right? And it helps us convert from one unit to another. You're going to use that same idea when you're changing from degrees to radians or radians to degrees. Okay? Somebody give me a degree measure. Give me a crazy one.
28.7.
367,000.
Okay, not decimals.
25.
Okay, 25 degrees. Okay?
It's pretty crazy.
Alright, 25 degrees. Let's change that to radians. Okay?
Oh.
So we're going to change 25 degrees to radians. So, what I need to do is I need to multiply that by a conversion factor. That will change degrees into radians. What's the relationship? What's one relationship you could say that this many degrees is equal to this many radians?
90 over. We'll do 180 over pi.
Great. 180 degrees is pi radians, correct? They're the same?
Yeah.
So how about I put 180 degrees down here on the bottom and pi radians here on top? Would that cancel out my degrees label? Absolutely. What's the only label left over? Radians. So right now I'm just going to do the math. 25 times pi, I'm going to leave it in terms of pi, it just makes things easier.
No, we're not cross
1 times 1, it's not a proportion, it's a fraction.
multiplying.
Okay? 25 pi over 180, I can reduce that, everything's divisible by 5, right?
5.
So 5 pi over, is that 36? I believe.
Apparently.
Okay? So 25 degrees is the same thing as 5 pi over 36 radians. Okay? Now if you wanted to, you could take 5 times pi, divide it by 36, and see what that is as a decimal if you'd like. But to me, this looks a lot nicer than some long decimal that's going to go on forever.
But the decimal wouldn't be wrong.
The decimal wouldn't be wrong. It'd be rounded, so it wouldn't be exact, but not wrong. I'd prefer you leave them in terms of pi. Okay? So, I took an angle that was in degrees, multiplied it by pi over 180, and now my answer is in radians. Okay? I'm going to go the other way. let's say I have an angle that is, let's go 11 pi over 6 radians. Okay? So 11 pi over 6. So in other words, I'm giving you an angle now that's in radians, and I want you to change it back to degrees. So what do you think I'm going to have to multiply by to get rid of the radians and change it to degrees? Where does the radians go? Bottom. So pi radians is 180 degrees, right? So the radians cancel, and now I can multiply. Well, I'm actually, to do this in my head, I'm going to do some canceling also here first. So I don't have such. Can't I cancel the pi's?
Yeah.
And doesn't 6 go into 180 30 times? So all I have is 11 times 30, so 330 over 1, so 330 degrees. Everybody see that? So 11 pi over 6 radians is actually the same thing as 330 degrees. So if you want to change from degrees to radians, you multiply by pi over 180. If you want to change from radians to degrees, you multiply by 180 over pi. Pretty simple. It's just like changing feet to miles, inches to feet, whatever it might be. Okay? So, how do you feel about changing from one to another? Is that okay? All right. Another thing real quick. Find your trig charts, your big trig table you made.
I never filled that out.
Oh, are you sure?
Okay? We didn't fill out the first 2 columns because that was meant for our radians. Okay? Also, if you have your unit circle, find that. That might help you here right now too.
I don't think I have it.
Alright, well, if I'm going to be searching for stuff, I'm not going to video me searching it.